Welcome to our channel. In this session, we are going to discuss about inheritance in Java. What is mean by inheritance? Inheritance means one object acquires the properties and behavior from another object, that is from parent object. So one object acquires the properties and behaviors from another object is called inheritance. That means one class have the features of another class. The process in which one class can have the features of another class is known as inheritance. Now, how do we achieve inheritance? By using the keyword extends. So, by using the keyword extends, one class acquires the properties from another class. What is the syntax? Class. For example, assume the class name is sample1. Here you are writing some body. Class sample2. Here you are writing some body. Initially, there is no relationship between these two classes. Now, after this class, by using the keyword extends followed by sample1, then the sample1 is the parent class and sample2 is the child class. Now, the members, that is the properties and behavior are in the sample1 are available to sample2 also. Now, sample2 consists of the members of the parent class along with their own members. Now, generally, we are creating an object for the child class. Why? By using that object, we can access members of the parent class along with the members of their own class. This is the point. In this way, we are using inheritance. What is the main advantage? Reusability. In any class, you can use the methods of the parent class. You can use any number of times. Next. So, this is inheritance. Mainly, we have three types of inheritance. In Java, mainly three types of inheritance. The first one is single inheritance. Second one is multi-level inheritance. Third one is hierarchical inheritance. Single inheritance, multi-level, hierarchical. Anyway, two more inheritance are there. One is multiple, second one is hybrid. So, hybrid is a combination of any two inheritances. In multiple inheritance is directly not achieved through classes. For this, we need another topic, interface. We discuss these multiple inheritance interfaces in the later sessions. Now, coming to the single inheritance, assume A is the parent class, B is the child class. So, parent to child. This is called single inheritance. What is multi-level? Assume A is the grandparent, B is the child, B is the parent, C is the child. Like this, you can use. So, not only three classes, you can move to any level. Grandparent, parent, child. Such type of relation is called multi-level inheritance. Third one, hierarchical inheritance means one parent to multiple childs. One parent to multiple childs. This is called hierarchical inheritance. Hierarchical inheritance. Now observe the point carefully. Here we are using these three types of inheritances. We are using three types of inheritances. In all the cases, the child class extends the members of the parent class. First, I will write down one simple example. After that, I will elaborate the topic. One simple example, class sample 1. Within this class, I have one method display. Assume one simple system dot out dot println. So some message in sample 1. Close this method, close this class. Now create one more class. Assume the class name is sample2 extends sample1. So for example, assume the method name is here display1. Assume the method name is display2. Here what happened? So sample1 is the parent class. Sample2 is the child class. Now this sample2 extends the method of the parent class. This is single inheritance class demo inheritance. Create main method public static void main string args of create an object for the child class. Why? Now logically sample2 consists of two methods. One is the parent method display1 along with their own method. So create an object for sample2 child class. Observe, by using this object, I am accessing the parent method display1 and I access the child method display2. Close this main, close. Here change some message. Now this is the program. I observe single inheritance. Simply the parent method is available to the child. Anyway, first to understand the structure, I will elaborate one by one. Save demo inheritance.java. Now go to the folder, click the command prompt, compile java c demo inheritance.java. So check any errors are there, no errors. Fine. Java space demo inheritance. So see this one. First to display one of the parent is executed. After this two of the child is executed. Now you understand. This is single inheritance. What is the multi-level inheritance? Grandparent to parent, parent to child. Minimum 3 classes. So create one more class. Understand the structure? Now assume the class name is sample3 extends sample2. Now sample3 consists of display1 method and display2 methods also. Why it extends sample2? Sample2 extends sample1. So internally sample3 consists of the methods of sample1 also. Now create an object for sample3. Call display1, display2, display3. Execute. See this one, sample1, sample2, sample3, all are executed. Now, coming to third one, hierarchical inheritance means one parent, multiple childs. Understand? Assume sample1 is the parent, sample2 is one child. So, extend sample1. Now, sample3 is also one child. It also extend from sample1. You got it? Now sample1 has two childs. One is sample2, another one is sample3. Now by creating an object for sample3, you can access parent method, that is display one, and their own method, display 3 only. Why? The parent method display 1 and display 3. Suppose if you want to access display 2, again you need to create an object. I think you understand the point. Why? We access only the parent members along with their own members. The parent members along with their own members only. See this one? Now you are getting one idea. What is that one? By using the child class, we extend the properties and behavior. Now I will extend the program. I have multiple cases. The first case one is variables and methods from the parent class. What I am extending? The variables and methods of the parent class are extended in the child class. Now, go to this one. Do one by one. Suppose class sample 1. Assume it consists of one variable A and static int B. Now what I am doing? In the sample one, I have a instance variable A and a static variable B, and I have one method display one. Within the display one, what I am doing? System.out.println. I am printing. Suppose A is equal to plus A. I am printing A value. System.out.println B is equal to plus B. Clear? Now what I am doing? In the sample one instance variable, one static variable. I have one display method. Display one, assume this is an instance method. Within this method, just I am printing A and B value. Now what I am doing? Write down one static method. Assume the method name is display2. So here I am changing according to this one. Display one. Assume this is display2, and you know that one. Within the static method, it is not possible to print instance variable. If you are trying to print, it gives an error. Clear? If you are trying to print, it gives an error. Okay. So system.out.println. Here I am printing only B. Here I am printing only B. I think fine. Now parent is created. Now what is your aim? Create one child class sample2, extend sample1. Extend sample1. Here what you want to do? Suppose do the same thing. Do the same thing like this. Int x, one variable. Suppose static int some y, one static variable. Now void display3 of in display3. So I extend the topic. In display3, system.out.println, print the values of x and y. X, system.out.println, print the value of y. Now this one is the display3. In the similar fashion, write down display4 method. Assume display4 is some static method. Assume some static void display4 of. Here in display4, anyway x is instance variable, it is not possible to print. Now understand? One parent class is created. Within this one, instance variable, static variable, instance method and static method. Now child class is created. Within the child class also I created instance variable, static variable, instance method and static method. Now sample2 consists of display1 and display2 also. Now what you are doing? Ignore this one. Coming to this main method, within this main, remove all this. Within this main, if you want, you can use scanner. Sc is equal to new scanner of system.in. Okay. Within this main, I am reading all the values. First, to create an object for the child class. Yes or no? Create an object for the child class. New sample2 of an object is created. Now, directly, you know that one. The instance variables are directly accessed by using an object, and by using object we can assign the values also. So ob dot a is equal to sc dot next int of. Okay, so just for understanding, I am printing some message system dot out dot println. Enter a value. Understand carefully. A is an instance variable in the parent. Anyway, that is available to the child also. Now, enter the value of B. So A is an instance variable. Through object, I entered the value of A. Now B is a static variable. How can we access static member? By using class name. What is the class name? Sample1. Anyway, here what is my topic? Inheritance. So whether it is a static member or instance member, that is available to the child class also. So observe sample2.b. It is possible. You got the point? It is possible. Sc dot next to int of. Clear? Like this, we can access x value and y value. In the similar fashion, we can access x value and y value, their own members. Enter x value. Ob dot x is equal to enter y value. So y is anyway available within this one. After reading all the values, call the methods. How to call the methods? Ob dot display1 is a static method, sorry, instance method, so called by using object name. Now sample2 dot display2. From this, what you observe, whether it is a static variable instance variable or static method instance method, whatever it is, whether it is a variable or method, that is available to the child class, that is available to the child class. Sample2 dot display 4 of. Sample2 dot display 4 of. Now save and compile the program. So scanner, okay, fine. So starting you need to write import java.util.scanner. Save, compile one more time. So no errors. Now enter A value, suppose 5, enter B value, enter C value, X value, enter Y value. Now see this one in display 1, A value, B value, display 2, only static, display 3, display 4. By using child objects, we are accessing all these. From this, what is the conclusion? All static and instance, all static and instance members of the parent class are available to the child class. So instance members are accessed. Instance members are accessed by using object of the child class. Static members are accessed by using class name of the child class. Why? All the members are available. All the members are available. Okay. Now, what is my next point? Case 2. Constructors. What is another programming component? Constructors from the parent class to child class. Parent class to child class. In this, the first one is zero parameter constructor. That is a constructor in the parent class without any parameter. Without any parameter. So, write down one program. Here, what happened? Suppose we have a zero parameter constructor in the parent class. Assume zero parameter constructor in the parent class. Then the compiler will add superof. Will add superof to the child class constructor at the compilation stage. We already discussed this one in compiler. Discussed this one in compiler. Anything? Check. Class parent. Assume for understanding, I used the class name as parent. Now, parent of, this is the constructor. Just one message, system.out.println. One message, I am in parent class. Close this. Close this. Here S capital. Now, create one child class. Class, assume the class name is child, extends parent. Extends parent. Within this one, create one constructor, child of. So, system.out.println. I am in child class. I am in child class. Close this class. Okay. Now, class demo inheritance, suppose 2. Public static void main string args of create an object for the child class. You know that one. Whenever you are creating an object, automatically constructor is executed. Now observe. Here what happened? Whenever, even though you are creating the child class, here internally it adds superof. This is done automatically at the compilation stage. Anyway, even though you are creating an object for the child class, first it calls the parent class constructor. Internally, it adds superof. Check this one. Compile. Java C demo inheritance 2.java. Okay. Okay. Demo inheritance 2. So, okay, I saved this one as the text file notepad. Save as demo inheritance 2.java. Now, system.out.println sys. Fine. Java space demo inheritance 2. See this one. Anyway, even though you are creating an object for the child class, it calls the parent. Why? Here I placed it inside the comment. I placed inside the comment. So this is not executed. Internally, the compiler adds this one. The compiler adds this one. Okay. Now, if you have a parameterized constructor, then what you need to do? You must add super of. You must and should add super of. For example, into some variable a. Here, if you want, you can print the value system dot out dot println a is equal to some variable a. Now, in the child class, you have, suppose we have a variable into some b or else into some a, you can use any variable, not a problem. You must and should add super of with this one parameter a. What happened? Whenever you are creating an object for the child class, we are called, this is executed within this one, this first statement. Whenever super means the immediate parent class constructor is executed, the immediate parent class constructor is executed. Now see this one, pass some value 5, save. See this one, first I am in parent class and then I am in child class and then I am in child class. You got it? So my second case is related to constructor. What is the next component? Variable is completed, method is completed, constructor is completed. Next, blocks. The blocks from the parent class to static block, parent class to child class. Okay, in this we know one point. What are the two blocks? Static block, instance block. Anyway, static block in the parent class, static block in the parent class has highest priority in execution than child. Remember, static block in the parent class has highest priority in execution than the child class. Similarly, instance block in the parent will have highest priority in execution than child class. Now, see one example. Here, if you want, I can change this example. In the parent, I used one variable static int a. Instead of constructor, create one static block. I am in parent static. Just for understanding, I am in parent static block. Print the value of a. Now create, copy this one. This is an instance block. I am in parent instance block print a. Fine. So in my parent class, I have one static block and one instance block. One static block and one instance block. Like this, what I am doing, simply copy. So in the child class, exactly doing one variable print I am in child static block, print the value of b. Print the value of b. So here I am in child instance block, print the value of b. You got it? So simple example related to block, static block in the parent, static block in the child, instance block in the parent, instance block in the child. Anyway, whenever you are creating an object, so without any parameter, what happened? What happened? Simply, whenever the class is loaded, first priority is for static block. So again, the child has static block and the parent also have static block. In that, the highest priority is given to the parent class static block and then child class static block. After that, the parent class instance block and then child class instance block. You know that one. So whenever the class is loaded, static blocks is executed automatically. Whenever an object is created, instance blocks are executed automatically. Check this one. See, first parent static, child static. After that, parent instance, child instance. Anyway, it prints all the values are 0. Why? Here I am not given any value. That is the reason only. I am not given any value. It takes the default values. No problem. If you given some value, suppose int a is equal to 2. Here, some b is equal to 3. So by default, static variable takes a value 0. So whatever the values you are given, they takes that particular value. Now you got it. This is the entire concept related to inheritance. One class, one object acquires the properties and behaviors from another class. What they can acquire? They can acquire variables and methods, constructor, blocks, instance variable, instance method, static variable, static methods. Now what you discussed, instance variable and instance methods are accessed by using child class object. Static variable and static methods are accessed by using child class name. Coming to constructor, even though child is there, if you have zero parameterized constructor, the compiler automatically adds super of. If it is a parameterized constructor, you must and should add super. Coming to block, so even parent and child consists of both. The highest priority is given to the parent class static block, and then child class static block, and then instance parent block, and then child instance child class, instance child one. This is the concept of inheritance. In this, we discussed single inheritance, hierarchical inheritance, and multi-level inheritance. Anyway, multiple inheritance is not possible to achieve. We can achieve multiple inheritance through interface. That's the end of inheritance. Thank you.